Page 3 of the polynomial models bookwork, number 5. The graph shows the tide heights, h meters, at the time t hours after midnight for the Blue Coast Harbor. So the tide is how high the water is at the beach. Use the graph to find the height of the tide at 1:30. Okay, well if this is 1 and this is 2, then 1:30 would be halfway in between. And the tide height looks like it'd be about, I don't know, if I eyeball it, maybe like 3.6 or something. 3.6 meters. And then the height of the tide at 5:30, so 5:30 would be about here. That looks like it's about 2. Okay. The time when the height of the tide is 3 meters. Okay, well 3 meters would be right there. So here's, one would be 2 hours after midnight, and the other one would be 6 hours after midnight. So I'd put 2 hours after midnight and 6 hours after midnight. Okay, so that's number 5. Exercise 4b. The times of high and low tides one day are modeled by this function. And this maybe will remind you of the modeling that we did, where we modeled a quartic function which has a fourth power, just like this one does. We modeled it to look like the camel back. So you kind of know what a quartic function looks like. It can go up and down a maximum of 3 times, right? So let's program the quartic function in the calculator, just like we did with the camel back. But negative 0.0015 x squared plus 0.056 x cubed. Oh, actually the first one, I'm sorry, 0.0015 x to the fourth. Change this to a 4. And then the next one is 0.056 x cubed. And the next one is 0.6 x squared. 0.6 x squared plus 1.65x plus 1.65x plus 4. Okay, where x is the number of hours after midnight. Okay, use your GDC to sketch the function for 0 to 20. So let's see what this looks like. We're going to sketch this function. Okay, it kind of went up and didn't come back, so maybe I didn't give it enough room here. So let's make the window height maybe like 30. Try again. Okay, now I'm thinking I typed this in wrong, so let's check this out. Negative 0.0015 x to the fourth plus 0.056 x to the third minus, oops, I put a plus there. That makes a difference. 6x squared, and then plus 1.65x plus 4. Okay, now let's try. Okay, and then we just need to fit a little bit more in here because it did say to graph it till x equals 20. Oops, that was a mistake. Oops. Oh, now it's got a graph. Okay. All right. Let's change our window so that it goes up to x max 20. Okay, now it'll be Perfect for copying. Something like that. Okay, so it's kind of like that. Okay. Now it says where x is the number of hours after midnight. Okay, so we graph this from 0 to 20, right? Use your GDC to sketch the function. Okay, we just did that. Find the time of the low tides. Okay, low tide looks like that. Find the time of the high tides. Okay, the high tides look like these two bumps. So how do we use the calculator to find that? We use second calc, and to find the high tides we use maximum. And since there's two, we have to specify to the calculator which one we want. So we actually give it the left bound. We go a little bit to the left of this bump. We hit enter. We go a little bit to the right of this bump. Hit enter. And then it says guess. You just go ahead and hit enter again. And then it thinks a while, and then it tells me that the maximum, this bump here, is has a certain points, which is 1.798. So 1.798 is actually 1.80 through three significant figures. And the y is 5.34. 5.34. So the time would be 1.8, and the height of the tide would be 5.34. Now let's find the other one. Second calc maximum. And then we're going to move the cursor to be a little bit to the left of the bump. Hit enter. And then we go a little bit to the right of the bump. There we go. Enter. And then the guess doesn't matter, just hit enter. So the maximum is 17.43, 8.57, 8.57, right? Because it's 8.568, yeah. Okay, so those are the two high tide points. The low tide points, let's see, let's find that one. We'll go second calc minimum, and then we'll go to the left bound. Hit enter, and then go a little bit to the right. And we'll hit enter. Then we hit enter again for the guess. And it tells me that for the minimum it's 8.77 and 1.22 is the height. So let's see what it's asking now. Find the time of the low tides. Well, the time of the low tides is 8.77 hours after midnight. And for the high tides, the times are 1.8 hours after midnight, and the other time would be 17.43 hours after midnight. This would be about, like 1:30 in the morning or later. This would be about, 5:20 p.m. or so. This would be like maybe 8:45, something like that. Okay? But you don't have to translate it. You just say 8.77 hours after midnight, 1.8 hours after midnight, 17.43 hours after midnight. Okay, next one. Here is the graph of the function f of x equals x minus 2 to the fourth plus 6. Find the value of f of x when x equals 2. So, find the value of f of x when x equals 2. Let's see, it looks like it's about 5 or so, but we can actually graph it because they gave us the function. So let's do that. Let's program it in. Okay. Let's see. Okay, so the function is parentheses x minus 2 to the fourth plus 6. Okay. And graph. Okay, so that looks like, similar. Find the value of f of x when x equals 2. Okay, well, there's a couple ways you can do that. One is you could use the second calc min function, which we already know how to do. The other way is you could just substitute x equals 2 in here, and we'll see what you get. Well, this is an easy one to figure out with, just manual calculation because 2 minus 2 is 0, right? So actually, it ends up being 6. So f of x when x equals 2 is 6. Find the values of x when y equals 6. Well, when y equals 6, we already know that x equals 2, right? Because we know that when x equals 2, y equals 6. So when y equals 6, x equals 2. It's kind of a trick question. Write down the range of this function. Well, as you can see, the range is the minimum y till the maximum y. And you can see from this graph that the maximum y is infinity. And the minimum y is, remember that it's the vertex, which is 2 comma 6. So the minimum value of y would be 6. Now, is it 6 is less than y, or is it 6 is less than or equal to y? Well, since it's a vertex, it's 6 is less than or equal to y, right? Because the value is 6 at some point. So you can just say that for the range. Okay. Okay, and that was it for page 3. Now you're ready for the quiz.